So the recording has begun. This is day number 4. Day number 4, week 6 of our journey together. And we're definitely glad that you're here with us today. Yeah, we are going to continue our journey with probability, continuing those questions. And today I'm going to talk about a sample space that we haven't really looked at extensively yet or in depth, and that is the standard deck. All right, so we're going to begin with that sample space, looking at the things that are in it, the things that are there, and then afterwards we are going to do a question based on the sample space, and then we're going to move on to the addition rule with probability. And the addition rule applies when the events are mutually exclusive, and that means that when we say mutually exclusive, that means that they cannot take place at the same time. All right, they're mutually exclusive. They cannot occur at the same time, or they do not have events. Sorry, they do not. The outcomes are they do not have any outcomes that are common. All right, they do not have any outcomes that are in common. That's what we mean by mutually exclusive. So let's look at. So we're gonna look at the standard deck, and then we're gonna look at the addition rule. That's probably the only rule we could be able to get through today. Or we might even have time for multiplication rule. So let's just see how far we get with things. All right. So sorry, let me that's is my screen sharing? Yeah, I think it is. Yes. So my screen is definitely sharing. Okay, good. All right, so new. Let me bracket that. Let's go. So today is Monday, Tuesday, Wednesday, Thursday. Today is Friday. Sorry, today is Thursday. What am I thinking? Today is Thursday, the 11th of August, 2022. The subject is, of course, mathematics. The topic is definitely, we're going to look at the standard deck, and we're going to look at addition and multiplication rule. For probability. Addition and multiplication rule for probability. So if we were to take an example of this, if we were to take if we look at a picture of the standard deck, so this is the standard deck. If we look at it, Now with the standard deck, we do not take into consideration the joker. All right, so I know that sometimes cards you have the joker, but when we look at the standard deck, we do not consider the joker. All right, so the joker is not a part of our accounting, so we don't look at the joker when it comes to the standard deck. All right, so let's look at it. All right, so this is a picture of the standard deck, so let me enlarge this some more. Okay, so let's see if we could send this weird. Interesting that it's built like that. Let me do it like this so you can see it properly. Give me one moment, let me fix it. So let's zoom in, and maybe I could move that there. I have this make all of these smaller so we can actually see it in one page. All right, so okay, so maybe it should work now. Okay, still a bit blurry, so I gotta show it on slideshow. Okay, that's better. All right, good. So if you look carefully, the standard deck has how much black cards? Anyone know? How many black cards do we see for the standard deck? Hello, are we here? Y'all can hear me?
Yes, sir.
How much
Yes,
black
sir.
cards do we see? Hello?
Hello, good afternoon, sir. How you doing?
26, yes.
Yes, sir.
Yeah, this is Macari Gordon's father.
All right. So if we look carefully, right, there are 13 black cards. All right. And sorry, 13 clubs and then 13 spades all together as a combined total of 26 black cards. 3 plus 3 is 6. 1 plus 1 is 2. So we have 4 suites. Each of these we call a suite. So we have clubs, spades, hearts, and diamonds. Or we'd say hearts, diamonds, spades, clubs. Now, if you look carefully, each suite or we'd say each denomination has one ace. And the ace, we usually could look at that as 1, right? But ace has a lot of power, especially in games. So we have the ace, each suite has an ace, and we have a spade, ace of spade. Then we have ace of hearts, and we have ace of diamonds. All right. Then we have 2, 3, 4, 5, 6, 7, 8, 9, and 10 for each of those cards. And then obviously we have the jack and the queen and the king. Each suite has 1 king, 1 queen, and 1 jack. All right. So this is the standard deck of cards. It's important for you to have a graphs of what's there. All right. So if we ask, okay, what's the probability of getting a red card? What's the probability of getting a black card? What's the probability of getting hearts? What's the probability of getting sorry, queen of hearts? So what's the probability of getting a queen, a king, whatever, a black king, a black queen, whatever. Those are some questions that we can play with the standard deck. All right. All right. So let's actually put this into words. All right. The standard deck. So standard So the standard deck, let me, okay, good. So the standard deck of playing cards contains 52 cards in total. There are 26 red cards and 26 black cards. The standard deck can be divided into 4 suites. Each suite we'd call them denominations as well. So instead of calling them suites, we can call them a denomination. Okay. And I know when you think of denomination, we think of church, but you know, that also works for these two as well. So the standard deck can be divided into 4 suites. Each suite has 13 denominations. And that is ace, 2, 3, 4, 5, 6. So my apologies. A denomination is not the category. A denomination represents each card in that category. So ace.
Pardon?
A denomination is not so each suite has 13 denominations, if you understand what I mean. So 4 suites. In each suite we have 13 denominations. So what I mean is, look. So this is the denomination. Sorry, this is a suite, club. Spade is a suite, hearts is a suite, and diamonds is a suite. Each suite have 13 denominations. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So each of them are considered to be a denomination. All right. So I move that. Sorry, move it. Okay, one moment. So each suite has 13 denominations. So ace, 2, 3, 4, 5, 6, 7, 8, sorry, 6, 7, 8, 9, and 10 are These are the denominations identified by number of spots. The three face cards. So the three face cards would be, of course, in each suite. Are the Jack, the Queen, and the King. Now these are also denominations as well. So 13 denominations, 10, starting from ace to 10, and the other three, which are the face cards. The one that has like a picture on it, which is just the Jack, the Queen, and the King. So hearts, diamond, spades, and clubs. Really, these should be in capital letter. Hearts, diamonds, spades, and clubs are the four suites with hearts and diamonds being the two red suites and spades and clubs being the two black suites. The interplay between suites, denominations, and colors is the basis of most of the card tricks and recreations performed with the deck. So it's important to know the standard deck, to be familiar with the workings of it, like what it actually looks like, what it actually feels like. So you have four. You need to know that there are 52 altogether. 4 suites, hearts, diamonds, spades, club, 13 denominations, ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, king, and queen. You need to know that there are 26 red, 26 black. You need to know that the hearts and diamonds are the red ones, and the spades and clubs are the black one. All right. And so that's basically what you need to know for the standard deck, or when we're dealing with the probability of a standard deck. Or then when we're dealing with probability along with the standard deck. All right. Okay, so let's look at example exercises that deals with probability with the standard deck. So probability and the standard deck. So a card is chosen at random from the standard deck of cards. Determine the probability that the card is a red card, a heart, or a spade. I say a heart, yeah. A king, sorry, an ace, sorry. A king, and a red queen. A queen, a red card that is a queen. Can't see. Can't see. My screen isn't sharing? I guess you can't see the top. Okay. Okay, good. I think that should do it. So those are our 5 probability questions. So a card is chosen at random. Okay. All right. So a card is chosen at random. Determine from the standard deck of cards. Determine the probability that A, the card is a red card, B, the card is a heart card, C, the card is an ace, D, the card is a king, E, the card is a red card that is a queen. And when we say a heart card, it would mean that it is a card that is of the heart's denomination. Maybe I should put that like that, just to be more. A card that is of the heart's denomination. Maybe that will be that's more specific or more rigorous. All right. Alright, so let's try the first one. Alright. Sierra, can you help me with the first one? What's the probability that the card is a red card?
1 out of 13.
1 out of 13? No. Think about it. So, what's our event? Our event is, what's our event E?
Okay. Choosing at random a red card
Okay, a red
from the
card
standard deck.
is chosen, yeah, from the standard deck, right? Okay, so that's the event. What is the probability of that event? So let's, the probability of E is going to be equal to, notice that we have, this is going to be fraction. So the number of elements in the sample space, in the event divided by number of elements in the sample space. Y'all know that school open on the 29th of August, right? By way of announcement.
Yes, sir.
Yeah.
Our school opens September 5th.
Your school opens September 5th. What school is that?
Windsor.
Windsor. Where's that?
Albany.
Windsor. That just opening.
No, sir. It's close to Lifer Key.
I know, but wait, are they building a new compound? Because I saw another school. I saw
Oh no, that's King's College.
oh, that's King's College. Okay. So I get the two mixed up. Okay.
My school opens on the 23rd.
The 23rd of what?
No, wait, hold on. The 3rd of September.
Oh, okay. You go to the same school as Caitlin, right?
Yes.
Okay, good. Yeah, okay. All right. Well, some people open on the 3rd, some people open on the 29th. But government schools open on the 29th of August. That surprised me. That really surprised me. Who opens government schools in August? That was a surprise. I don't remember going to school in August. So then there's that, right? I guess there's a first to everything. So yeah, August. That's what? 2 days from now? All right, so a red card is chosen from the standard deck. So how much we have in total, Sierra? How much elements in the sample space?
26.
46. Why you get 46?
26.
Sample space.
Is it?
Sample space.
That'll be 26.
Sample space. That means in all. So let's look at our cards. How much cards we have in total?
52.
52. Very good. 52. Okay. We have 52 cards in total. So that's gonna be sample space 52. Good. How much red cards do we have? Sierra.
26.
26 red cards because we have 13 that's from hearts and 13 that's from diamonds. If we look carefully, we have 13 hearts and 13 diamonds. So 13 plus 13 is 26. So that means that it'll be 26 over 52. Now, Deja, can we simplify this further?
Yes, sir.
Okay, what do we get when we simplify it?
I got half.
Get a half. Very good. Because you divide both of them by?
Well, I just realized it now. I could have used 26, but I got and divided by 2, and then I divided by 13.
Oh, okay, yeah. So if we use 26, 26 divided by itself is 1, and 26 goes into 52 twice. All right, so it's a half. And it makes sense because, literally, it's half. Like, literally, half of this is red. What do you think the probability of getting a black card is going to be? Anyone?
Won't it be the same thing?
Yeah, it's the same thing. It's a half. So the probability of getting a red card is going to be 1/2. A half. Okay, good. Let's do B. So Deja, help me with B. I want, what's my event?
Um, you say denomination? Oh, okay.
So what's my event?
A card chosen from the heart's denomination.
Very good. A card is chosen that is of the heart's denomination. Basically, it's a heart card. Ain't got no. Say it again. Say it again. What'd you say? Shouldn't you? Oh, I guess you're talking to someone else.
Um, I think there's 13 denominations in heart, so
Uh-huh.
the numerator would probably be 13.
Probably. You like your probably boy. Why you can't just say it straight up? You like the guess. No, you don't like the guess. You like the question yourself. You don't like the guess. You like the question yourself. Don't do that. Probably. I give you the formula and I give you the standard deck. So, probably. All right. So what it is?
13 over 52.
Very good. You're gonna stand by that?
Pardon?
You're gonna stand by that?
Uh, yeah, go.
Thank you. Yeah, stand by your logic. That's all it is, Logic. Yeah, my brain is more powerful than yours.
Let me simplify it. You get 1/4.
Yes, 1/4. So how did we get 13? Because notice that there are 13 hearts. If we look carefully, at the standard deck, right? There is ace of hearts, two of hearts, three of hearts, four of hearts, five of hearts, six of hearts, seven of hearts, eight of hearts, nine of hearts, 10. Jack is 11, queen is 12, and king is 13. So there's 13 hearts. So it's going to be 13 out of 52. Okay, 13 out of 52. All right, so that means if we go back here, it's going to be 13 out of 52. But if we divide top and bottom by 13, 13 goes into itself once, and 13 goes into 52 4 times. So it's going to be 1/4. 1/4. All right, Caitlin. What's going to be my event for C? Go ahead, Caitlin. What's going to be my event for C?
Caitlin said a card that is chosen of the ace.
A card that is chosen of an ace? Huh?
I don't know.
Go ahead, Caitlin. Her mic isn't working.
I don't think so.
Okay. Cyan answered then. What do you think? It's my event.
A card is chosen from the ace denomination.
Mm-mm. The card chosen is an ace. Okay. Okay, so we just want an ace. Okay. What would be the probability of me getting an ace? Cyan. What's the probability of that event?
1 second.
I could barely say it again.
Ten over 52.
10 over 52. Why you say 10 over 52? Hello, Sayana. Why you say 10 over 52?
Ciano.
Yes, Sienna. Go ahead. Why you say 10 over 52?
Because 15-2 is the standard deck, and I'm not sure, but like what you wrote,
Oh, okay.
like
All right. How much ace do we have in the standard deck? Go ahead, Caitlin. How much? Sorry. Go ahead, Sienna. How much ace do we have in the standard deck?
two.
Okay, I see 2. And how about these 2?
Oh,
So how much altogether?
4.
4. Very good. So there are 4 aces altogether. So that means how much? So what's gonna be my probability of getting an ace?
452.
Very good. 4 over 52. Deja, simplify it for me, please. What we get?
1/13.
1 over 13. Because 52 divided by 4 is 13. And 4 divided by 4 is 1. So it's 1 over 13. Here we divide by 4 to get 52. I mean to get 1. And we divide by 4 to get 13. 4 divided by 4 is 1, and 52 divided by 4 is 13. Now, Jasmine, what's going to be my event for D? Jasmine? Hello, Jasmine. Can you speak, please? Because I can't. What happened? Is your mic working? I need to hear your voice. Go ahead, Jasmine. Is your mic working? Okay. I guess not. So go ahead, Deshaun. Help me out with D.
A card chosen as king.
The card chosen is king. All right. What's the probability of that event? Deshaun, what's the probability of that event?
3.
Okay, let's look back at the standard deck. How much kings do we have?
That's 4.
4. Very good. So there are 4 kings. 4 kings in the standard deck. Hello, Albanique and Antonique. Hey, Albanique. What happened? Y'all didn't know classes today? Hey, Albanique.
I just forgot.
Say it again. Did you say Albanique?
I said I just forgot.
Oh, you forgot. Yeah, you can forget. You got to be with class every day except for Friday and weekend. So, yeah, that's strange. All right, y'all missed a lot so far. So again, it's 4:52. So please be on time for class, all right? And when I send the link, pay attention to the link. That's why I send it almost before class time to remind you. All right, so check your phone. So 4:52. What number we could use to simplify that, Deshaun?
4.
4. What is 4 divided by 4?
1.
1. Very good. And what is 52 divided by 4?
13.
13. Good. So it's 1/13 as well. Next thing we want is the probability that we get a red card that is a queen. All right. So I'm gonna ask Miss Johnson to help me with this. Miss Johnson, what is the event?
The card that is chosen is a queen.
Not just a queen. It ought to be what?
The card that is chosen is a red queen.
Very good. The card that is chosen is red and is a queen. Okay. Good. So what's the probability of getting that event? Go ahead, Miss Johnson. What's the probability of getting that event?
2/52.
Okay, 2/52. Why you say 2/52?
Because there's only 2 red queens.
Very good, because there are only 2 red queens. If we look at the standard deck, we have 1 queen, which is Queen of Hearts, and the next queen, which is Queen of Diamonds. They are the only 2 red queens. The other ones are black queens. So it's going to be 1 and 2. So it's 2/52. So 2/52. And if we were to simplify that, what would we divide by, Miss Johnson?
2.
Good. 2 divided by 2 is what?
1.
1. And what is 2 divided by 52? What is 52 divided by 2? That's basically half of 52.
26.
26. Very good. So it's 1/26. So the probability of us getting a red card that is a queen is 1/26. The probability of us choosing a king is 1/13. The probability that the card is an ace is 1/13. And the probability that we get a card that is of the hearts denomination is 1/4. Okay, so with that being said, we are going to do some exercises using the standard deck. All right, there's still a host of questions we can ask you based on the standard deck, and so we're gonna play with that. Now remember, the standard deck has 4 suites, 13 denominations. The 4 suites is hearts, diamonds, spades, and clubs. 13 denomination in each suite. That's ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, king, queen, and we also have that the card is separated or divided into 2 equal parts. We have 26 red cards and 26 black cards. The black suites are going to be your spades and your clubs. The red suites are going to be your hearts and your diamonds. All right, so you have to get an understanding of how your standard deck looks, how it works, so that if any questions comes on that, you would be able to answer them quite correctly. All right. So when we say picture cards, remember we're talking about cards that has a picture. So we're talking about like the jack, the king, and the queen. That's what we mean when we say picture card. Okay. Okay, so let's do some exercises. I need this to be a part of my evening classes. So determine the probability that A, the card is a black card. B, card is a card from the spades denomination. C, a card is it's a jack. A card is a black king. And we can have the bonus ones. We want the card is a picture card. And the next bonus is the card is any number from 2 to 10. So E and F are bonus questions. We didn't really do an example say of them. So alright, so I'm going to give you a few moments for this one, and you can try it on your own. And the timer, I'm going to give you 3 minutes today. Let me be kind today. This is our last day of the week, so let me be kind and give you 3 minutes. Go ahead, Sienna. I see your hand raised.
Can I do A?
You want the easy one? I want you to do E or F, man. Okay, Sienna? I'll let you do A
A.
though. No, I'm just pulling your leg. Alright, so we want the probability. So Sienna wants to do the black card. So there's another way we could say it. We could say probability of black cards. We don't have to do like probability of E. We could just put black card in there as a black or black card, either one. The idea is the same thing. What's the answer for this one, Sienna?
26/52.
Very good. 26/52, because there are 26 black cards, right? 13 clubs, 13 spades, 26 black cards. All these combined is 26. 13 clubs and 13 spades. So that gives us 26 black cards. How can we simplify this?
And divide by 26.
Divide by 26. Very good. So it's going to be 1 over what?
2.
2. Very good. Okay, Jasmine, I want the probability that I get a spades. Is Jasmine here? Okay, I'm not hearing from Jasmine. Okay, Miss Neely. F Neely. F Neely.
Yes, sir.
Yes, ma'am.
Yes, ma'am.
What's the probability of getting me
What's the
spades?
probability of getting states? You didn't do it, right?
Yes, ma'am. B.
Okay. 104. I got
Um,
104.
Before you get 1/4, what do you get?
Before you get 104, what do you get? Oh, I divide 13 over 52. I mean, 13 over 52.
13 over 52.
13 over 52. Yeah.
How did you get 13 over 52?
How did you get 13 over 52?
Like, why you put 13 to?
Like, why you put 13? Okay. Okay, the card from the stage. The card from the stage, and it's 13. 13 stage?
There are,
That's not together.
okay, so there are 13
Okay,
spades.
so there are 13 spades. Yeah.
Okay,
Okay.
very good.
Very good.
So 13 out of. Give me one moment, please. Hello?
Hello?
Yes, ma'am.
Hi, sorry, Mr. from this number.
One moment. Hello? Can you hear me now?
Yes, sir.
Okay. So it's 13 out of 13 out of 20 out of 52. And like you say 1/4 because we divide the top by 13. 13 into 13 is 1. And 52 divided by 13. Oh gee. $52 divided by 13 is 4. All right. Okay, now jack. The probability that we get a jack. Um, Miss Johnson, can you answer this for me, please? Probability that we get a jack. Miss Johnson, what's the probability that we get a jack? Hello, Miss Johnson, are you there?
Yes, sir. Sorry. 52.
Why you say 4 out of 52?
Because there's only 4 jacks.
Okay, there are 4 jacks. Okay, if we look carefully, like she said, there is 1, 2, 3, 4 jacks out of the full deck of 52 cards, and so that means that our probability is going to be 4 out of 52. Very good. If you were to simplify it, what do you get, Miss Johnson?
By 4.
Mm-hmm.
Um. By 4.
Yeah. And what do you get when you divide the two?
1 over 13.
1 over 13. Very good. Okay, now the probability that I get a black king. Caitlin, what's the probability that I get a black king? Say it again. Very good. 2 out of 52. And when you simplify it, what do you get? Caitlin, when you simplify it, what do you get?
One over 26.
Okay, what number you use to simplify?
2.
Very good. So we divide top and bottom by 2, and we get 1 out of 26. Alright. Alright, who want to do E? Anyone want to volunteer to do E?
I can.
Okay, gotta go.
Okay, go ahead. I think that's
Me?
Yeah, go ahead.
Okay, so
You want to do the bonus? You
really?
missed out myself every day. You
Okay,
alright
so
then.
you said every sweet has 3 faces. So
Uh-huh.
you have 4 sweets, so I multiply 4 times 3 and I get 12.
Uh-huh.
So I got 12 over 52.
Okay.
And then I simplified it by 4 and I got 3 over 13.
Okay, and you sure about that, or are you kind of guessing your way through, or
I
what you
mean, I attempted. I'm not sure.
attempted? Okay. Picture face. So, picture face would be these cards: the Jack, the King, and the Queen. All right. So there are 3 picture cards in spades. Sorry, in clubs. 3 picture cards in spades. 3 picture cards in hearts. 3 picture cards in diamonds. So that's 3, 6, 9, 12. 12 picture cards, like Deja said. When you divide them, what do you divide them by?
4.
4. All right. Divided by 4. What you get afterwards?
3/13.
3/13. Okay. That's correct, because 24 divided by 4 is, sorry, 12 divided by 4 is 3, and 52 divided by 4 is 13. Okay, Sierra, probability of any number from 2 to 10.
5/10.
5. Don't just think about one denomination. So let's look at it. Any number from 2 to 10, from 2 to 10. So that'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. Okay, so you understand what I did?
Yes, sir.
Okay, so I want to pick any number between 2 and 10. All right, and this is altogether is 36, because we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 numbers, 9 numbered cards that actually have the number on it. So if you multiply that by 4, you get 36. So it's going to be 36/52. And when we divide that, 36 divided by 52, what do we get when we divide 36 by what do we do, and sorry, what do we get when we simplify it, rather?
Get 9/13.
Okay, what do you use to simplify?
4.
4. 9/13. So 9/13, and that is, my friend, probability with the standard deck. Yes, ma'am. That's us. I feel like we get in somewhere. We've come a long way with probability. Come a mighty long way. When did we start probability? Last week or this week? Anyone can answer? I'm asking generally.
I think we started this like last week.
Last week? Okay. With sample spaces and events and experiments, complement, union, mutually exclusive events. And then we come all the way to the probability definition, number of elements in the sample space, number of elements in the event. A bunch of examples yesterday, from farming to a paper manufacturer, the class president, all type of examples. And today we are on a major sample space, which is the standard deck. All right, and we're looking at how to manipulate it and how to deal with it. Very good sample space that we are considering. Now I think we're ready for the addition rule. So we're ready for combined probabilities now. Yes, I said it. Combined probabilities. The first rule that we're going to be looking at is the addition rule, and this only happens, or we only could use this rule when the two events are mutually exclusive. And like we talked about some time back, with mutually exclusive events, they cannot occur at the same time. So the probability of getting a head and a tail, that's impossible, because you can't get a head and a tail at the same time. It's just impossible. So that means that their intersection is 0. The probability of getting an even number and an odd number when you roll a dice, we can't, their probabilities are, sorry, the intersection is 0. We can't have even and odd at the same time. It's just impossible for us to do that, because if it's even, it's not odd. If it's odd, it's not even. So they are mutually exclusive events. All right. Hey, Jasmine.
What's up?
I've been trying to get your attention from a long time. What's been happening?
Yeah.
Oh, you couldn't hear it since. Okay. All right. I'm glad to have you back. I was like, where's Jasmine? So glad to have you back for the second segment. So
Okay.
we're moving on to addition rule for probability. And like I was explaining, this only applies for mutually exclusive events. All right. This is gonna be cool. All right. I don't know about y'all, but I just love the process of learning, because when you learn, it destroys your ignorance. Like before you didn't know, and now you know, and it's like, wow, I really didn't know that. I didn't know it could be done from that perspective. And so it's like working out your muscle, right? You're getting bigger and bigger and bigger and bigger and stronger, and so it could endure more. And yeah, so we're gonna be looking at combined probabilities. All right. The first one, the first rule we'll be looking at, and so this is the beginning, Miss Deja. Where's Deja when you need her most? This is the beginning of the tree. All right. Okay, Deja.
Okay.
This is the beginning. You need to know these two rules for the tree. If you want to do well in the tree, you need to know these two rules. So combine probabilities. This is the heart and soul of the tree. And this question comes every time, generally speaking, when they bring the tree. They ask you a addition rule and a multiplication rule question. Okay.
Honestly, all I knew was I saw lines and some fractions, and we were like, fill out the tree. And I was like, okay, I can just put the same thing back. And then I didn't know what to do from there.
Oh, so you was just doing a past paper on your own, or you was doing it in class?
I mean, I was just practicing it, but I was lost. And I went online, and I still was lost.
No, man. Online should help. YouTube videos help a lot. I ain't gonna lie. With math, oh my goodness. That's how I went to college. Oh my goodness. Thank God for YouTube. I'm telling you, thank God for YouTube. So let's move this. Good. So if events A and B are mutually exclusive, i.e., they cannot happen at the same time, then the following rules apply. Then the following rule apply. The probability of event A, or, this is a very important word, or, I can't emphasize that enough, or, probability of A or B equals the probability of A plus the probability of B. Now, the thing is, right, we also supposed to subtract the probability of A intersect B. That's what we're supposed to do. But the thing is that the probability of A intersect B, remember, these two events are mutually exclusive. So the probability of A intersect B is 0 because they can't happen at the same time. So that's why we have the shortened definition, whereby we do not include that at all. All right, and we just have it as such. So the probability of A or B equals probability of A plus the probability of B. That is your addition rule. Okay. Okay, so that's.
I mean, I don't get it because like on the paper they'd be like, what's the chances you get both a black and a white car? But I just was lost.
Yeah, so that's the multiplication rule when they say both a black and a white car. That's and. All right. They also got ask or questions. All right. So they'd say the silver car or the white car. Right. Something like that. So in that case, you have to first find the probability of getting the white car, then find the probability of getting the silver car, and then add them. Okay. So, example.
The probability and probability plus the probability of the silver car.
Yes. So you have to find the probability of the white car, and then find the probability of silver car, then add them. Okay. That's way down the line when we get the trees. All right. The first example is, remember, this works only when we're dealing with mutually exclusive events. That means the two events cannot occur at the same time. So a box contains 6 blue balls, 4 red balls, and 5 white balls. What is the probability of picking out from the box either a red ball or a blue ball? Now, the reason why these two events are mutually exclusive is because you can't pick out a red ball and a blue ball at the same time, because the experiment is that you are picking a ball one at a time from the box. All right. So a box contains 6 blue balls, 4 red balls, and 5 white balls. What's the probability of picking out from the box either a red ball or a blue ball? So the first thing we're going to do is we need to first find out the probability of A. So the probability of getting a red ball. What's the probability of getting a red ball, Sierra?
6 out of 16.
6 out of 16. You say 6 out of 16. Why you say 16?
I added 6, 4, and 5.
Yeah, 6, 4, and 5. So 6 plus 4 plus 5 is 16. So maybe I should put that 6 plus 4 plus 5. That's how we got the 16. So the probability of red is going to be 6 out of, the probability of getting a red ball is going to be 6 out of 16. All right. Deshaun, what's the probability of getting a blue ball?
Um,
Mr. Petit, the
Yeah,
red is four
the
to
red
six.
is 4. Yeah, I just noticed that.
yeah,
I just noticed
that
that.
threw me right off
I
because I
just
was like,
noticed
what?
that. Yeah, I just noticed that. Yeah, the
It's
red is,
6. 16.
yeah, 6 out of 16. Yeah,
Well, that's a free answer for me, I
I
guess.
know, right?
Wait a minute, how that's 16? And 6 plus 4 is 10, and then 10 plus 5 is 15.
6 and, yeah,
Oh, yeah.
15. Oh my goodness, we out of
What's
whack
your?
today. We out of
My
whack.
goodness, mom, this is deep,
We
man.
out of whack. Come on, Sierra, you lead me to the dungeon. Oh my
My
goodness.
You
mind
had too
so
much
far.
food today, Miss Petit.
I trust in Sierra, you know. I'm like, man, Sierra ain't gonna lead me wrong. But see, the way I
Come on,
think,
Sierra.
oh my goodness. This is embarrassing. Ah,
You have me writing 16.
yeah, it's
I
four.
don't know.
My
Yeah,
goodness.
yeah, boy,
Now,
embarrassing.
if it was 5 red balls, then it would have been 16.
Yeah, yeah, that's true. Wow, my mind didn't even check that. I was like, yeah, that look right. 16 is right because 6 and 4 is 10, and then you add 5, you get 16. I don't know how in the world I add 5 and get 16. Oh boy, okay. So it is 4 out of 15, very good. And 6 out of. Don't worry, I just testing y'all. I just is making sure y'all, um, you know, focusing. That's all. It was all a part of my plan. Mm. Right, Dylan? All right. Okay. But honestly,
I have a question. So
go ahead.
you don't have to.
No, don't simplify it.
You don't.
Don't simplify it because you're gonna add them. So
Okay.
you simplify it when you finish one time. Okay. So the probability of getting red or blue, we're gonna add what? The probability of red plus the probability of blue. Okay, so it's gonna be the probability of red plus the probability of blue. That's gonna be equal to 4 out of 15. 4 out of 15 plus 6 out of 15. That equals to what? What is 4 out of 16? 4 out of 15 and 6 out of 15 equal to
10 out of 15.
10 out of 15. Very good. 10 out of 15.
Excuse me.
Yes, ma'am.
So like instead of putting all that, you could just like put like 10 or 15.
Um, well, the reason why I did like this is because I want to show you the addition rule. But if you're able to do the addition rule in your mind, then yeah, it's the same idea. So what is 10 over 15? Simplify to
12.
2 over 3. Very good. We could also look at the probability as you can also look at OR as the union. So when we say probability of A or B, that's actually, we could actually represent that as, let me put it here, that's actually equal to probability of A union B, interestingly enough. So the union is OR. The union is OR. The intersection is AND. That's interesting. So the union is or, and the intersection is and. So it's the same thing. Alright, so let's look at some examples. I am going to, this is an example. I think I'm gonna show y'all in the fire one time. So exercise, let's do exercise right off the bat, alright? So here's the exercise number 1. An exercise states the following. A bag contains 8 red discs, 4 blue discs, and 1 white disc. What is the probability of picking out a either a red disc or a blue disc, B either a red disc or a white disc, C either a blue disc or a white disc, and D either a blue disc or a white disc or a red disc. Alright, so that is exercise 1. So you have a few moments to answer that, and I'll see you after the break. So do your best with this one. About 3 minutes on the clock. So we want probability that we get either red disc or blue disc, red disc or white disc, blue disc or white disc, or blue disc, white disc, or red disc. Remember, we applying the addition rule for probability. All right, that's time. Okay. Sienna, can you help me with A? What's the probability of red or blue?
Um,
Go ahead. Hello, Sienna, are you there? Go ahead, Sienna. We want the probability of either red this or blue this. We didn't hear you. Something is wrong with your mic. So I didn't hear you. Go ahead, Caitlin, answer for, because I'm not hearing from her. Go ahead, Caitlin, answer for, please, because I can't hear from her. Okay, let me try Miss Johnson then. Go ahead, Miss Johnson. Are you there? Red or blue? Hello, Miss Johnson. Are you there? Let me try Miss Jasmine. Jasmine Blue.
Okay, I put P red disc or the blue red disc.
Mm-hmm.
The red with 8 plus 4
8
over
over
13.
Okay, so 8 over
That's
13
12 over 13.
plus 12 over 13. Overall it's 12. Yeah, overall it's 12.
Yes, 12.
Good, that's excellent. All right, Miss Neely, F Neely, red or white? What you get for that?
So, I play red, this is 8, and the white, this is 1,
Mm-hmm.
and 9, and I around them, because it's 18, so 9 is 18.
Okay, so Very good.
Very good.
8 over 13 plus 1 over
8 over 13
13
plus 1 over 13
equals 9 over 13.
equals 9 over 13.
Now we want the probability of blue or white. This is for Albanic. Blue or white.
Okay, so I got 4 over 13 plus 1 over 13 equals
Mhm.
5 over 13.
Very good. So 4 over 13 plus 1 over 13 equals 5 over 13. Good. Okay, probability of blue. This is for you, Sierra. Or white.
This might be wrong, but
Or red. Or red. Go ahead. Don't doubt. Don't be like Deja now. Don't doubt yourself.
I know it might
Like
be wrong
Dalinito.
too. Okay, I got 13 out of 13.
Which is what?
1.
1. And that is absolutely...
I get all of them right.
Who said they get all of them right? Who said that?
Jasmine.
Jasmine says she get all of them. Alright, but we didn't even say the answer for this one is yet. Jasmine, have so much confidence. What if I answer wrong, Jasmine? 4 out of 13 for
I
blue.
know my answer right.
Oh boy.
13 over 13 is 1 whole.
It's a whole. Very good. 13 over 13. White is 1 over 13. And red is 8 over 13. And so that's going to be 13 over 13, which is a 1. This is a good time to tell you, I haven't said it before, but if your probability is a 1, that means it is a certain that you will get either blue or white or red when you put your hand inside that bag. That makes sense because only blue, white, and red in that bag. Let me ask you question E. I should have put question E out. This is another one. It's a probability of me getting a orange disc out of that bag. Anyone know what's the probability of getting the an orange disc?
0?
Deja, you asking or you telling me?
0.
Yeah, it's 0 because it's impossible for me to get. It's really 0 over 13 because it's 0 disc out of 13 disc, but 0 to 13, as we learned in the 0 properties, is 0. So 0 means impossible, right? In the world of probability, so 0 means impossible. It shall never happen, right? 0 means impossible. And 1 means certain. Definitely gonna happen. 100% chance. Alright? Certain. Alright? Yes?
That means that you like get like certain percent of the time red.
Say it again. That means what?
Get a time you get a certain percent of time you get a red disc.
I can barely hear you. That means what?
If you get like 8, if you get like 8 over 13 plus 8 over 13 plus 13 over 13, that means we get a 8. That's when you get a red disc.
Okay, so like how does have blue, white, or red? So that's 8 over 13 plus 1 over 13 plus 4. That means that it is certain, we know for sure, 100%, that when we put our hand inside that bag and pull it out, we either gonna get a red one, a white one, or a blue one. Okay, so it's 100%, we're 100% sure that we either gonna get a red, or white, or blue, because it's only them three colors in there. So when we put our hand in it and we pull something out, we definitely gonna get either a red, a blue, or a white. But we know we are not gonna get an orange, because how we get orange if there are no orange there? There are no orange discs there. That's why it's impossible for me to get an orange disc, because there are no orange discs to choose from. Okay, that's the idea for orange. It's impossible. Can't happen because there are no orange. Okay. Oh, excuse me. Okay, that's the addition rule. Let's look at another example. So for addition rule, we add. All right. Let's look at another exercise. Exercise 2. Exercise number 2. All right. For exercise number 2, so the first one is talking about choosing disc out of a bag. The second one is a small, let's say we have a small box of chocolate. It contains 4 hard centers, 6 soft centers, and 2 foil wrapped chocolates. What is the probability of picking out either a hard center or a soft center, B, either a hard center or a foil wrapped chocolate, C, either a soft center or a foiled wrapped chocolate, D, not a soft center, and E, banana. Ice cream. Alright, so that's the exercise. We're gonna give you some time for that. And the timer has begun. Alright, that's time. Go ahead, Albanique.
Okay, for my number one answer, I got 4 over 12 plus 6 over 12 equal 10 over 2.
Okay, so we're trying to get either a hard center. Sorry, let me do this properly. So Erase this.
What?
So we're trying to get either a hard center or a soft center. So the probability of hard center, I'm gonna just denote that as HC, or a soft center, denoted as SC. It's gonna be what would you say?
I said 4/12 plus 6/12 equal 10/2.
4 out of 12. 6 plus 4 is 10. Plus 2 is 12, yes. Plus what?
You mean after 10/12?
4 over 12 plus what?
Plus 6/12.
Plus 6 over 12, very good. That's going to give us 10 over 12. Excellent. And we could simplify that to give us what?
5/6.
Yeah, divide the top by 2. Divide the bottom by 2 is 5 over 6, very good. Probability, thank you. Probability of, why put fully? It's supposed to be foil. Foil wrapped. So probability of hard center. So hard center or foil wrapped. It's gonna be what, Jasmine? Jasmine, what you got for B? Okay, I'm not hearing Jasmine. So Sienna, what you got for B? Go ahead, Sienna, what you got for B?
Can you hear me?
Yes, I could hear you.
Um, four over 12.
Mm-hmm. And what else?
Plus 2/12
Plus 2 over 12. Good. What would
equals 6.
very good. Can we simplify 6 over 12?
Yes, divided by 6.
And that gives you what?
1/2.
1 over 2. Alright. For C, go ahead, Jasmine. C. Jasmine, can you do number C? C? Can you do letter C, please? Oh, we can't hear you. Something wrong with your mic. So soft center or foil wrapped. Go ahead, Miss Johnson. Are you there? Miss Johnson, are you there? Go ahead, Caitlin. Caitlin.
So it's 6/12 plus 2/12 equals 8/12 divided by 4
Okay.
equals 2/3.
3 over what?
6/12 plus 2/12 equals 8/12 divided by 4 equals 2/3.
Okay. All right. Thank you. 6 over 12. Jasmine said 8 over 12. Thank you, Jasmine. 6 over 12. That's soft centers. Foil wrap is 2 out of 12. And that's 8 out of 12. Divide top and bottom by 4, we get 2 over 3. Very good. Caitlin and Jasmine. Deja, not a soft center.
Since you said it, I assume that everything else we'd have to find. So I find hard and foil. And I got 4 over 12 plus 2 over 12. I got 6 over 12, and then when I simplify, I get half.
Right, I think that makes sense. Yeah, because they say not a soft center, so we can't include anything else. So not a soft center would be either a hard center or a foil wrapped center. So it's going to be the same thing as numbers. It's the same thing as B, which is a 6 over 12, which is a half. Sierra, what's the probability of a banana ice cream?
0 to 12.
Which is what?
0.
0. And what does that mean?
There is no banana ice cream.
More than that, that means it is what?
Possible.
Uh-huh. So say it again. It is.
It's impossible to get a banana ice cream.
Yeah, it's impossible.
Because there's only chocolate.
Yeah, it's impossible for you to get a banana ice cream. Very good. All right. Okay, very good. So that would be it for math. We're gonna transition over to. So we did the addition rule today. Excellent. I thought that was excellent that we did that, and we also did the standard deck. Okay. So standard deck and the addition rule is very important. We did those two. The standard deck and the addition rule, very important ones that we did. So we're gonna move on to English today. So remember, please don't forget to send in the class notes. Some of you are faithful in sending them, and then others of you are just not faithful in sending them. So please be faithful in sending them. Don't send one this today and then the next. Be consistent, right? Call it consistency and momentum. Consistency and momentum. So make sure you send them to me. Did I put exercise 1 out? I didn't put exercise 1. So any questions on this? Is it easy, hard, medium? How you feeling? Anyone can ask? Say it again.
If you ask us the question, is easy, hard, or medium?
Yeah, that's what I'm asking. Yeah.
Easy.
Easy. Okay. Addition rule, standard deck, and what? Standard deck and addition rule. All right, so that's it. That's that. Last class for English, we did. This what we did that yesterday. 10th. No, this couldn't have been us. Was this us?
Yeah, so that's what we did yesterday.
That was us. Okay. All right. Yeah. Sorry. Yeah, Altwinique. Yeah, there we go. Okay. All right. All right. All right. Okay. Joining clauses. All right. Okay, so let's continue right in the same thread, so we won't get confused. Yeah, we did joining clauses, and I promised that we are gonna do combining sentences, but we're gonna change one part into what? A subordinate clause. Didn't I say that? Okay, so let's do that for today. I don't know if she is there. So, Sierra, how would we combine it?
Although we were frightened.
You could go up a bit, please.
I want to use the coordinating conjunction right here.
Okay, we were frightened. Although
Not although.
we were frightened.
What made them frightened?
The ride.
Okay.
So we were frightened before. Hold on. We were frightened because the ride went so fast.
Yes. Very good. Very good. We were frightened because the ride went so fast. Okay. And so there you have it. We use that sub-coordinating conjunction because to help us combine them. So another example would be, so this one is uncombined. Let me allow y'all to see. I don't know, this giving me some weird looks. I don't know why they don't want to. What is this? Yeah, you sure? I want it like this, but I don't know, it's just weird these days. Maybe I need to zoom it in. Okay. Okay. Alright. I don't know if that helps. Maybe this helps. No, that's voice. Let's see. Alright. Okay, I think that was the problem. Oh, gee. Even smaller. Let's see. No, that's crazy. So I have to change it to this. Okay. So that's the, sorry, let me scroll up. Scroll up again. Okay. So that's the first one that we did. Uncombine and then combine. Let's look at another one. All right. So what do I say? Jamie. So this is uncombined. And we're gonna use another sub-coordinating conjunction. So if I said, not Jamie, let's say, yeah, uncombined. Let's say we rode the, this isn't carousel. I pronounce it carousel, but I like that the yeah, it's carousel. Carousel. That's the actual pronunciation. It's funny. I was like, wow, interesting. That's how they actually pronounce it. Like, interesting. All that time I've been pronouncing it wrong. But it looked like carousel, but it's actually, again, actually had the pronunciation.
Carousel.
Yeah.
Carousel.
Carousel. Carousel.
Carousel.
Yeah, carousel.
Carousel.
Yeah, carousel. Carousel. Okay, that makes sense. I could buy that. Carousel. Yeah. Carousel. Okay. Okay, I can live with that. Carousel. Yeah, that's what it is. It's the merry-go-round, right? Remember we saw that before. So we rode the carousel and we rode the Ferris wheel. All right. That's it uncombined, right? Now, if we want to combine, how would we combine them? Which subcoordinating conjunction would we use? Deja?
Um, I guess you could say we rode the carousel after we rode the Ferris wheel, or we rode the carousel before we rode the Ferris wheel.
Excellent. So we rode the carousel after we rode the Ferris wheel, or before, whatever happened, in your case. So we rode the carousel after we rode the Ferris wheel. And then next we have uncombined. We can say Jamie rode the log flume to cool off. The day was so hot. So I said uncombined. How can we combine it? Deshaun, how could we combine these two sentences?
Which wait,
These two sentences we're trying to combine.
oh, Jamie rode the log flume to cool off because the day was so hot.
So you would load the log film to cool off.
What is a log flume?
Let me show you. Let me show you a picture. Look, it's something that people use to cool off themselves. Okay, now you can understand why she would go on it, right? It's a water event. All right. So she chose to go.
Okay.
Yeah. So she chose to go on this. To cool herself down, and shoots, this thing look fun. Oh, this look fun.
For those who can swim.
Do you know have this? Do you have to be able to swim? Shoot, just put on a life jacket. If these people have their whole clothes on, why would they go with all their clothes on? I mean, you want to go. I mean, you want to be dressed appropriately. I mean, that's true. So let me not say that, but I hope this is not their only change of clothing. That's my concern. But hey, then there's that. Log rides. All right, so where were we? Okay, sorry. Yeah, this is what I want. I don't know what font I have this on. This is what 48. Okay. Okay, so number. Okay, so Jamie wrote the log form flume to cool off. We could say since instead of using because again, since the day was so hot. But because is a better one. Um, uncombined, we can have Brendan tried the roller coaster. He doesn't. He does not like loops. So how could we combine this, Deja?
I guess you could use even though.
Even though,
Yeah, you could say Brandon tried to try the roller coaster even though he did not like loops.
you mean although?
And even those one?
That's not one I gave y'all.
Okay,
You
well,
mean
I'll
unless?
go then.
Say it again.
She mean unless?
No, not unless. Unless wouldn't work. Although is better. So Brandon
Oh
tried.
yeah.
Yeah, although Brandon tried the roller coaster, although he did, he does not like loops. Alright, so I'm gonna leave it at that. I'm not gonna slay you all. So we could call it that. So once you finish the notes, you can leave. And please send in the class notes right after you leave class.
I on the
Especially
first line.
you on the first line. Who said that?
The last. The last.
You on the last what?
The last uncombined.
Okay, okay, okay. I thought you say on the first line. I was like, what? Okay, yeah. So once you finish, send it to me, please. But besides that, have a wonderful night, and I'll see you tomorrow. Not tomorrow. Monday, God's Spare Life at 6 p.m. All right. So if you're ready, complete it, you can leave. Have a wonderful night.